In November of 2023, something went wrong 15 billion miles from Earth. And for almost 5 months, nobody at NASA knew exactly what it was. A spacecraft that had been flying since 1977, a machine older than most of the engineers working on it, suddenly stopped making sense. It was still alive, it was still transmitting, but everything it sent back was garbage. Not silence, not a dead signal. Something stranger. A steady stream of noise with no meaning inside it, arriving from a point so far away that light itself needed more than a full day just to make the round trip. This is the story of how that happened, why it very nearly ended one of the greatest missions humanity has ever launched, and how a small team of engineers on the other side of the planet managed to reach across billions of miles and fix a computer from 1977 without ever laying a hand on it. To understand why this moment mattered so much, you have to understand what Voyager 1 actually is. It launched from Florida on September 5th, 1977, a few weeks after its twin, Voyager 2, which had already left Earth a little earlier that same summer. The mission was supposed to be simple. Fly past Jupiter, fly past Saturn, take pictures, gather data, and then fade quietly into retirement. NASA gave it a working life of about 4 or 5 years. Nobody involved in building it expected it to still be running half a century later. And yet, here we are. Voyager 1 flew past Jupiter in March of 1979, sending back the first truly close images of that planet's swirling clouds and its strange, violently active moons. It flew past Saturn in November of 1980, using the planet's enormous gravity like a slingshot, both to study the rings up close and to fling itself even faster and farther out of the solar system. Then it just kept going. It kept going past the orbit of Pluto. It kept going past the point where sunlight becomes too faint to read by, into a region so far from the sun that the difference between day and night stops meaning anything at all. In December of 2004, it crossed something called the termination shock, the point where the solar wind, the constant stream of particles blowing outward from the sun, suddenly slows down from supersonic to subsonic speed as it starts pushing up against the pressure of interstellar space. That was just the beginning of the outer boundary, not the end of it. By 2010, instruments on board noticed something strange. The outward speed of the solar wind around the spacecraft had dropped essentially to zero, and the whole region turned out to be filled with enormous magnetic bubbles nobody had expected to find there. And then finally, in 2012, Voyager 1 crossed the heliopause itself, the true outer edge of the bubble our sun creates around the entire solar system. On the other side of that boundary lies interstellar space, the region between stars, a place no human-built object had ever physically entered before. Voyager 1 became the first. It is still out there right now, more than 15 billion miles from home, moving at roughly 38,000 miles an hour, carrying instruments and computers built with technology that predates the pocket calculator, the home video game console, and the personal computer. The spacecraft runs on something called a radioisotope thermoelectric generator. In simple terms, it carries a small amount of plutonium that naturally gives off heat as it slowly decays, and that heat gets converted into electricity through a set of thermocouples with no moving parts to wear out. At launch, the system produced around 470 watts, enough to run a full set of scientific instruments, cameras, heaters, and radio equipment all at once. Nearly 50 years later, that number has dropped to roughly 220 watts, because the plutonium itself is slowly being used up and the equipment that converts heat into power loses a little efficiency every year as well. Every single year, without exception, Voyager 1 loses a small amount of usable electricity, and there's no way to add more. No refueling mission will ever reach it. No solar panel could help it either, since sunlight this far from the sun is thousands of times weaker than it is on Earth. What it has on board is what it will have until the day it finally goes quiet for good. Because of this hard limit, NASA has spent years slowly and carefully switching off Voyager's instruments one by one, trying to stretch the mission for as long as science can still be done with what little power remains. Of the 10 scientific instruments the spacecraft originally carried, most have already been permanently shut down, including cameras that were switched off decades ago once the spacecraft had passed the outer planets and had nothing left nearby to photograph. Every decision about what to turn off next is treated with enormous care inside the mission team, because once an instrument out there loses power, there is no bringing it back. There is no second chance, no repair visit, no software update that restores it. Whatever gets switched off, stays off. This was not the first time Voyager 1 had scared its own engineering team either. In May of 2022, the spacecraft began sending back telemetry data, the routine engineering information about its own orientation and health that simply did not make sense. Numbers that should have described the spacecraft's position and movement looked scrambled and impossible. Suzanne Dodd, the project manager overseeing both Voyager missions, described the situation at the time with a kind of weary calm, essentially calling it business as usual for a spacecraft this old. It took months of investigation before engineers figured out what had actually happened. One of Voyager 1's onboard computers, A unit that had technically failed years earlier and had been sitting unused ever since had somehow switched itself back on and was quietly corrupting the data before it ever left the spacecraft. It was a bit like discovering that a light in an abandoned room of your house had turned itself on without anyone touching the switch. Engineers sent a command redirecting the data through the correct functioning computer instead, and within a matter of days, the readings became normal again. In the roughly 3 months it took to work through that particular mystery, Voyager 1 had already traveled another 100 million miles farther from home. So, by the time late 2023 arrived, Voyager 1 was already an old, fragile, carefully managed spacecraft running on a shrinking budget of electricity, with a recent history of strange and unexplained glitches. Then, on November 14th, 2023, the team at NASA's Jet Propulsion Laboratory noticed something was wrong again, and this time it was worse. Voyager 1 was still responding. It was still receiving commands from Earth and appeared, as far as anyone could tell, to be carrying them out correctly. But the data it was sending back had turned into a repeating pattern of ones and zeros that carried no actual information whatsoever. One engineer compared it to being stuck in a loop, like a scene from a film where the same day keeps repeating itself over and over with no way out. Imagine picking up a phone call from someone you know well, hearing that the line is open, hearing that they are there and listening, but every single word that comes back to you is scrambled static with no meaning inside it. That is roughly what the Voyager team was dealing with, day after day, week after week. The spacecraft hadn't gone silent. It had simply lost the ability to speak clearly, and nobody yet understood why. This is where the real difficulty of the situation becomes clear, and it has almost nothing to do with the kind of problem you or I would face fixing a broken computer at home. Voyager 1 is so far away that a radio signal, even traveling at the speed of light, the fastest anything in the universe is able to move, takes about 22 and a half hours to reach it, and then another 22 and a half hours for any response to make the journey back. That means a single question and answer, one basic exchange of information, takes roughly 45 hours to complete from start to finish. You cannot troubleshoot the way you normally would with a computer sitting in front of you. You cannot try something, watch it fail instantly, and adjust on the spot. Every single test the engineers wanted to run had to be written out with extreme care, checked and rechecked internally, transmitted across the solar system, and then the team simply had to wait. Wait a full day for the message to land. Wait again for whatever reply came back, if anything came back at all. Then study that response, however incomplete or strange it looked, form a new theory about what might be happening inside the spacecraft, write the next set of instructions, and start the entire cycle over again. For 5 straight months, this slow, deliberate, nerve-wracking rhythm was the daily reality for the people trying to save Voyager 1. There was no rushing it. There was no way to skip a step. The distance itself set the pace, and the pace was brutal. The engineers eventually traced the fault to something called the Flight Data Subsystem, one of the spacecraft's 3 onboard computers, and specifically the one responsible for gathering information from Voyager's remaining instruments and packaging all of it, along with engineering data about the spacecraft's own health, into a single stream that could be transmitted home. In late February and early March of 2024, the team sent what they nicknamed a poke, a carefully designed command meant to gently nudge the flight computer into running through different sequences of its own programming, in the hope that doing so might reveal exactly where inside the system the fault was hiding. On March 3rd, something in the returning signal looked different from the usual repeating gibberish. An engineer working with NASA's Deep Space Network, the worldwide system of giant radio dishes that keeps contact with spacecraft scattered across the solar system, managed to decode it. Buried inside that signal was a complete readout of the flight computer's memory, something the team could finally sit down and study line by line, almost like being handed the patient's full chart after weeks of guessing at symptoms from outside a closed door. What they found was both simple to describe and deeply frustrating to face. Roughly 3% of that computer's memory had been damaged. A single chip, worn down after 46 years of continuous operation in the harsh radiation environment of deep space, or possibly struck at some point by a stray high-energy particle, had failed. Engineers described it as a stuck bit, a tiny piece of memory frozen permanently at one value instead of being able to change as needed. And that chip did not just hold random disposable information. It held a small piece of the actual programming code the computer needed to read every time it tried to do its job. Losing it was little like tearing a handful of pages out of the exact middle of an instruction manual that a machine has to consult constantly just to keep functioning. On Earth, this kind of failure has an obvious solution. You open the machine, you locate the damaged chip, and you swap it for a new one. None of that was remotely possible here. Voyager 1 sits far beyond any distance a repair mission could ever physically reach, and even setting aside distance, no spacecraft fast enough to catch up with it currently exists. No astronaut alive could survive a journey that long, and no realistic timeline could ever put a repair crew there before the mission's remaining power ran out anyway. The chip could not be fixed, it could not be replaced. It could not even be safely ignored because without that missing code, the computer had no reliable way to properly format and transmit any of Voyager's data at all. Whatever solution existed had to work completely around the damage rather than repair it directly, using nothing but instructions sent from 250 million kilometers away. The team's answer was almost elegant in how simple the underlying idea sounds, even though actually carrying it out was incredibly delicate work. If part of the computer's memory was permanently gone and could no longer be trusted, then the missing code needed an entirely new home somewhere else inside the system. The problem was that Voyager's onboard computers are almost unimaginably tiny by any modern standard, each one holding a little under 70 kilobytes of memory in total, an amount so small that a single ordinary photo taken on a smartphone today would dwarf it hundreds of times over. There was no single block of empty memory anywhere on the spacecraft, large enough to hold all of the missing code in one continuous piece. So the engineers broke the affected code apart into smaller sections instead. They went looking for scattered, unused pockets of memory across the system, some of it left over from features Voyager no longer needed at all, such as data transmission modes designed for when the spacecraft was still relatively close to Earth and capable of sending information back at much higher speeds, settings that had become completely irrelevant this far out in the solar system. Piece by piece, the team relocated the broken code into these small gaps wherever they could find room. But moving code around like this is nothing like copying and pasting a file on a modern laptop. Each relocated section had to be carefully rewritten and adjusted so that every piece would still function correctly and communicate properly with every other piece, even though they were now scattered in different physical locations across the computer's memory rather than sitting together the way the original programmers had designed. It was, in every meaningful sense of the word, a form of surgery performed entirely remotely on nearly 50-year-old software, through a communication delay of almost 2 full days for every single step of the procedure, with absolutely no room for a mistake that could not later be reversed. On April 18, 2024, the team finally sent the command containing this relocated code up to Voyager 1. Then came the wait, the same wait they had grown painfully familiar with over the previous 5 months, roughly 22.5 hours for the signal to physically arrive at the spacecraft. Then more time again for whatever response Voyager 1 sent back to make its own long journey home. On April 20th, 2024, readable, coherent data finally began arriving on Earth once more. After 5 long months of static and silence dressed up as noise, Voyager 1 was speaking clearly again. The fix had worked. A team of engineers, many of whom were not even born when the spacecraft first launched into space, had reached across more than 15 billion miles of empty, freezing void and successfully repaired a piece of 1970s hardware using nothing but patience, careful step-by-step reasoning, and radio waves traveling at the fastest speed the universe allows. What makes this story worth telling is not only the cleverness of the fix itself, it is what that fix actually protected. Because Voyager 1 is not simply an old machine limping along for the sake of nostalgia or sentiment. It is, right now, at this very moment, the only functioning scientific instrument humanity has ever placed in interstellar space. Since crossing the heliopause back in 2012, it has been sending back information about a region of the universe that no telescope sitting on Earth and no mathematical model built from the ground has ever been able to observe directly from the inside. And what it found out there did not match the predictions scientists had spent decades building. For a long time, researchers expected interstellar space to be relatively calm, a thin and quiet region where the sun's influence simply faded gently away into nothing, like the edge of a ripple in a pond. Instead, starting in 2017, instruments on board Voyager 1 began detecting persistent oscillations in the surrounding plasma, a kind of continuous, faint hum that scientists are still working to fully explain even today. Some researchers believe this comes from a natural vibration of charged particles reacting to their environment, a phenomenon that would fit inside existing physics without requiring anything to be rebuilt from scratch. Others believe it may point to something called quasi-thermal noise, a different underlying physical process that would require the existing models of the interstellar medium to be meaningfully revised. Nobody has fully settled the question yet. Either way, the data suggests that the space between stars is a far more active, structured, and dynamic place than anyone expected before Voyager 1 actually got there and started listening. This is exactly why the 5 months of silence in late 2023 and early 2024 felt so significant to the people working closely on the mission, even if it barely made a ripple in most people's daily lives back on Earth. It was not simply the possible loss of one old spacecraft among many. It was the possible loss of humanity's only real-time window into a part of the universe we have never been able to study any other way, and likely will not be able to study again for decades. If the flight data subsystem had never been successfully repaired, Voyager 1 would most likely have continued drifting silently through interstellar space, its remaining instruments technically still active and still measuring, but with absolutely no way left to report anything useful back to Earth. All of that unique, irreplaceable data, the readings still waiting to be taken, the discoveries still waiting to be made, would have simply vanished into a void, broadcast outward with nobody able to receive or understand a single word of it. The mission is not out of danger, and realistically, it never fully will be again. Power keeps dropping every year, a few watts at a time, steady and unstoppable, and more instruments will eventually need to be switched off permanently as the spacecraft's tiny remaining reserve of electricity continues to shrink toward zero. NASA's own engineers already expect that sometime in the early 2030s, the total power level will finally fall below what is needed to keep even a single instrument running, and Voyager 1 will go silent for good, this time with no long-distance repair possible. There's also a major milestone already locked into the calendar before that final silence arrives. On November 18th, 2026, at just after 2 a.m. Pacific time, Voyager 1 will become the first human-made object in history to reach a distance of exactly 1 light day from Earth, a distance of roughly 16 billion miles. At that point, a signal sent from Earth will take a full 24 hours just to reach the spacecraft, and any reply, if the aging equipment is still able to send one, will take another full day to travel back home. 2 entire days simply to complete one single exchange of information with a machine that is still, somehow, after nearly 50 years, listening and responding. Even after Voyager 1 eventually stops transmitting for the last time, it will not stop moving. There's nothing out there to slow it down. No air resistance, no atmospheric drag, nothing strong enough to meaningfully pull it off its current course. It will simply keep traveling in a straight line through interstellar space at roughly 38,000 miles an hour, carrying with it the golden record. A gold-plated copper disc bolted to its frame that holds greetings recorded in 55 different human languages, along with the sounds of falling rain, ocean waves, and human laughter, and 90 minutes of music chosen from cultures spanning the entire history of our planet. It is, quite literally, a message built to outlast everyone who ever built it, riding on board a machine that will likely still be drifting through the galaxy long after every trace of human civilization on Earth has faded away and been forgotten by time. What happened in late 2023 and early 2024 is easy to overlook if you only glance at the headlines from that spring. The spacecraft glitched, engineers eventually fixed it, and life on Earth went on exactly as it always does. But sit with the actual details of it for a moment. A team of people, working with a machine built decades before most of them were even born, diagnosed and repaired a failing computer chip from a distance so enormous that ordinary human intuition genuinely struggles to hold it in the mind. They did it with patience, with careful step-by-step reasoning, and with a willingness to wait nearly 2 full days between every single attempt, over and over, for 5 straight months, never once knowing for certain whether the next signal would bring good news or confirm that the mission was truly over. They did it because the alternative was losing our only working set of eyes and ears in a part of the universe we have never been able to reach any other way, and may not be able to reach again for a very long time. Voyager 1 was never supposed to last this long. It was never supposed to leave the solar system at all, let alone keep functioning from the other side of it, sending back data that continues to challenge what scientists thought they already understood about the universe. And yet, here it is, right now, still flying, still listening, still speaking to us across 15 billion miles of near total silence, purely because a small group of dedicated engineers refused to let one broken chip be the end of a story that had already defied every expectation ever set for it.